Everyone, welcome. What's up? This is page 428, and we are talking about theorems for chords of a circle. And so this lesson, we are definitely going to go through a proof of the chords of a circle. So have something to highlight, have something to write with. You're going to need some, maybe like a ruler, definitely note cards, and we're going to flip back and forth maybe through the book a couple of times. Let's get into what this question is. One question for this page because it's a 2-column proof. You can see it. Here it is. All right. Part of the proof thing, and anything in a math class, is that you do actually understand, like you've thought about what's being presented, and you're thinking about it with a way of maybe telling someone else. And so if I look at the diagram that's over here of this circle, and there are letters all over the place, and you can start thinking of words that they spell to help your brain think about like what's actually being referenced better than if you just let it be D-E-O-A-I and don't actually like put them into like a word, make a word out of them. Okay. After we do that, we're going to maybe add some highlight color from the given statements and then put them into the 2-column proof. So here's our first thing to highlight. Mi, me, is a diameter of circle O. And since that's true, I'm going to get one highlight color out. I'm going to highlight with my highlighter. Oh, I need to run around the room without my highlighter. Don't go anywhere. Okay, I got it. I don't got it. Ah, I found you. Oh my gosh, you should have skipped that part. Hi. Mi is the diameter of circle O. I'm going to highlight Mi. And then I'm going to go over here to the given. I'm also going to highlight that statement. I want to make sure that I see those two things. They are visible. I can use them. I can do something with them. Next up is Mi, me, is perpendicular. This is the symbol for perpendicular, which means that two lines are crossing at a right angle. You know, flip through your cards and find it. So I need to find me and da, mi and da, and highlight them so that I see, yep, there it is, they are perpendicular. Here's chord da, da, and here's the little perpendicular box that they're talking about. So it kind of turned green because blue and green, right? Blue and yellow make green. Now, those two, when they're visible, we can start doing something with them. All right, now what we need to do is prove. The previous page said that a perpendicular bisector of a chord is going to also bisect the arc on the outside. So that's our goal, is to figure out how it's possible that they could possibly bisect. Me is going to bisect da, and me is going to bisect the arc from D to A. Those two things are the goal in our 2-column proof. All right, first up, the given and the given. Those two things we have to specify right away, right out of the information that's there. And then notice something else is happening. They use this word under construction. That's technically also a given, literally by saying connect O and D to form radius OD. So maybe let's bring in some green on this one. Connect O to D to form radius OD and radius OA. In our picture, that's radius OA and that's radius OD. Now, by looking at that, I'm thinking isosceles triangle. And so probably at some point, I'm going to be using that, but let's just see where things go. And also, it might help if we separate line by line so that we don't like blend steps. That is not level. That's a little better. Okay, a little better. All right, let's go step 3. Step 3 is going to recognize that, you know what, if we have a perpendicular, so bringing back the word perpendicular up here, choose my letter, choose my color. This symbol right here, because it's literally that upside down T shape, that's going to go right here for my statement number 3. And that is not helpful of a size. Let's go like that. You can go. Okay. Number 3. Because of the definition of perpendicular. What's actually created as perpendicular? Let's take a look. So we'll look back up here, up here, up here, up here. This angle right here. In fact, I'm going to choose angle OEA and angle OED. OD and OA. Angle O and EA angle OEA and angle OED. Yeah, that's right. Are right angles. All right, that's the first new information, and it is literally because that shape up there was used. The perpendicular shape tells us we have to use the word perpendicular. Next up we have is that makes the triangles be right triangles. So I talked about like an isosceles triangle being there at some point. What the? Oh, you're much better. Okay, so since we have right angles, and those right angles are part of a triangle and a triangle, then that tells us we better make a statement that says how they create right triangles. So statement 4, triangle OEA and triangle OED are right triangles. Which is literally because right angles is used. So we're going to use that statement as our next reason. Because, I don't need to say the word because. Definition of right triangles. DEF, definition of right triangles. All right, cool. So we've got another statement along the way. The goal is to prove that that line DA is being bisected, and the arc that is created from D to A is bisected. But here we are, one more step further. We have the ability to actually say that, well, we're up to 4 lines now, 4 lines of code, and let's keep going. These are probably going to continue to be tilted. Sorry, just deal with it. Now let's go with the next one here. If we have a right triangle, and we have the inside of a circle, take a look. I kind of hinted at this. I'm going to make sure I comment as an actual statement in the proof. OD, OA, they're radii of a circle. So OD and OA are congruent. 5. Okay. Radii in a circle are congruent. Okay, statement 5. That is OD and OA are congruent. Okay. It looks like we're kind of setting up like some sort of equal triangle, like one triangle and the other triangle are the same. That way, if those 2 triangles are the same, then the sides that correspond, DEAE, are going to be congruent by CP/CTC. So I'm going to jump into the next sentence here, statement 6 and statement 6. And in this one, I'm going to say, you know what? The 2 triangles that we have, they share a side in common. That side that's shared in common is OE. Take a look. OE is shared by both triangles. So because OE is shared by both triangles have that side in common. That side is congruent to itself. And we say reflexive property. Carry on until students get here. Let's go. Yeah. This year when I'm recording it, students are getting ready to take a test. Oh, okay. 7. Guess what? That means that the triangles are actually congruent. So 7, the triangles, triangle OEA is congruent to triangle OED because we have a hypotenuse. That hypotenuse is ODOA, and a leg. And the leg that I'm talking about is this one. This is a leg. Here's the hypotenuse. So I'm going to draw a little like, this is the hypotenuse that I'm talking about, and this is the leg that I'm talking about. Those 2 things are what we needed to say to show that the triangles are congruent. Since the triangles are congruent, that therefore means EA, ED are the same. And I'm running out of space right here. Let's see if I can add another page real quick. Add, insert, This is a picture. I want a page. No. I don't want to mess with that. I might pause the video here and continue on the next page. So we'll go ahead and do that. There are 8, 9, 10, 11, 12 to go. So I hope that you either have something ready to insert into page 428's notes, or you're ready to just write small for the rest of part B video. Thank you for watching this video and sticking around. I will see you on the next one.